Okay. Good morning, everyone. Thank you all for turning up this morning. Hope you're all well where you are. This is the first lecture in a series of about 11 lectures that I'm aiming to present somewhere within the next year, with the eye on the fact that we have a number of students in the group who are kind of being exposed to radio astronomy as a field for the first time. People who are coming in completely fresh, potentially, not having had any radio astronomy lectures even before. So the good news about that is that it's not impossible to learn a new field like that. For my undergraduate, I did physics, and then postgraduate honors and masters, I worked on gamma ray astronomy. So I never had any real formal education on radio astronomy. When I started my PhD, I kind of had to pick a lot of this stuff up. So it's not impossible. It's don't let it intimidate you. But the idea behind today's lecture is to hopefully make that transition a little bit easier than it was for me, or for people who are just joining the field. So it's intended to be a very limited in scope, kind of a survival guide for new radio astronomers. And the impetus of it was me basically sitting down and thinking about the things that I wish that I knew when I started in radio astronomy about 8 years ago now for my MSc. Please make sure to mute yourself if you are not muted. Okay, cool. So, first, before we get to any of that, let me introduce myself a little bit. For those of you who don't know me, my full name is Mechiel Christiaan Bezuidenhout, but I appreciate that's a bit of a mouthful, so you can just call me Tian. I did my bachelor's up to master's at Northwest University in Potchefstroom in South Africa. And then in 2018, I left to Manchester in the UK to do my PhD there at the Jodrell Bank Centre for Astrophysics. In last year, I returned to South Africa to do a postdoc again at Northwest. And then since the beginning of this year, I've been doing my postdoc at Unisa. I work in time domain astronomy. So that's studying astronomical objects that change on some short timescales. So that typically is pulsars and fast radio bursts. Those are my main sources of interest. I work on different surveys that are trying to discover new instances of these sources. And then I also do some multi-wavelength follow-up campaigns of them using different telescopes. So I'm also interested in the instrumentation of radio interferometry and doing software development. Right. So in today's lecture, I want to touch on three topics. First, I want to tell you a little bit about the basics of research methodology. I think a lot of you are going to be familiar with this already, but it's useful a lot of the time. Nobody tells you this in explicit terms. So just to make sure everybody is on the same page. Then I want to give you a little bit of a flavor for what radio astronomy in South Africa is like, what the landscape is, what are the different organizations that are doing radio astronomy in South Africa. And then finally, I want to talk about what a career in astronomy looks like typically, and give you some tips for how to navigate that. All of this with the very important caveat that this is all really based on my very limited experience alone. In the first place, I'm still pretty early in my research career, so I'm sure some of the more senior people in the room are going to have a wider perspective, and I hope that they are willing to share their experiences as well. Secondly, since I'm doing time domain astronomy, I think besides me and my student Kevin, we are the only ones doing that kind of astronomy in the group. And one thing that you'll learn about astronomy is that every subtopic of a subfield of a subfield of a subfield has its own unique way of working and standard procedure and that kind of thing. So I can only claim to speak from my particular niche sub area, but I hope I can make it broad enough to at least be insightful. And then thirdly, this is all very much from a South African perspective. I know we have people in the group and call who are working from different countries in Africa. I apologize for being South African centric. I just don't really know much about how things work in other countries to say too much. So apologies for that, but I hope it can still be interesting. So yeah, by the way, we'll have a session for some questions at the end of this, but you're welcome to put your questions in the chat so long as well. So the first question I want to address is in terms of research methodology is a basic question. How do I find articles about radio astronomy? The first really important tool that you're going to have to learn to use, I'm sure a lot of you already are familiar with this already, is called the NASA ADS, Astrophysics Data System. And this is your probably your number one friend when it comes to researching astronomy. So this is a repository of pretty much all of the research papers that have been published in peer-reviewed journals in fields like physics and astronomy. And it has a really useful search function that allows you to find specific papers that you would be interested in. So I know a lot of the more senior people prefer to use the classic form of ADS. I'm a neophyte, so I'm pretty comfortable with the modern form of this. So I'm going to use that to demonstrate this a bit. If you go on the main page there, you end up with a search prompt like this, and there's a bunch of recommendations for different keywords that you can use. Probably a really important one that you will use is the author keyword. If you use a hat before the name, then it searches for paper where the person is the first author. If you remove the hat, it will give you papers where that person is any author in the co-author in the paper. So I've searched for author Chibueze J. So this is going to give me all of the papers that somebody called Chibueze J has authored as a first author. And there it gives you a list of different papers. Very useful thing about ADS is that it's your main tool for citations. So if I click on a particular paper, I can click on that little thing to show the preprint of the paper, so to give me a copy of the paper. I can look at citations, so who has cited that paper, that's often quite useful. Get a list of the references in the papers, and then the citation export is really useful. So for an export citation, probably to clipboard. And then hopefully all of you are going to be using LaTeX or Overleaf for writing your thesis and your papers. And there should be a BibTeX file in that where you can just copy and paste that citation into it, and then use a cite function in LaTeX to produce exactly the correct citation for that paper. So that's super useful. The other things that might be interesting about or useful about ADS, a search term I quite use quite often is full. So this is going to search all of the papers in the database for anywhere that some specific term appears. So if I search for SR, this is going to give me all of the papers in the database where anywhere in the text that the term pulsar appears. So in this case, that search term is super wide, so you get like 120,000 results. That's not really useful. But maybe more useful is if you search for a specific source. Okay. Oh, no, 1 minus 46. So that's a specific pulsar. And if I search just for that, it's going to give me only papers that mention that or that has that search term in it. There are a bunch of other keywords in this tool. I recommend just going through them. Some of them are useful. Keyword is often quite useful. And then, of course, the year is also important. So if you have a specific paper in mind that you've read, a citation in another paper, you can search by the author and the year that it was published. Right. And yes, all of these links I'm going to send out the slides as well, so you should be able to click on the links to follow them. Another really useful repository or a useful thing if you are especially starting out on a topic and want to learn more about a specific subject is to read review articles. So review articles are different from other papers in that they're not doing any original research. They're just synthesizing a bunch of information from different sources and putting it all into one source. So if you want to learn about pulsars, for instance, you can search for a review paper about pulsars, and that's going to tell you a lot about that. So Springer Link is a really good has a really good search function that you can limit it to review papers, and you can see I search for pulsars and I found like 537 review articles mentioning pulsars. Also really useful is the annual reviews website. That's a journal dedicated to reviews. You can just search for your keyword there and it gives you a list of review papers that you should find useful. Right. Another source that I recommend checking out is different student theses. So different universities often have online repositories where they post the MSc and PhD theses of previous students. I don't know if that's the case for Unisa, I didn't check. But if not, I recommend asking your supervisor especially if there are other students who have worked on similar topics before you, if you can read their thesis. Don't copy them, of course, but oftentimes they will have a really good list of very relevant references to your work. So that's highly recommended. And then the archive is also a really important thing. If you don't know about the archive, it's this repository for, it's an open access archive. So when you publish in a peer-reviewed paper, you submit a paper. When it's accepted, it's encouraged to upload your paper onto the archive as well, so that anybody can then access it. It's not behind a paywall. So the idea is to have as much as possible papers put on this open access archive. And if you open it up on the homepage there, you get a bunch of different subfields. Astrophysics is very usefully at the top of the page. If you click on that, there are subcategories. I think most of you are working on galaxy stuff. I work on high energy astrophysical phenomena. So if you click on new, it gives you a list of all of the papers that have been put onto the archive today. So 9 new papers have gone on the archive today. The really useful thing about archive is if you scroll all the way down, there's a button called subscribe. If you click on this and follow some steps, it tells you how to subscribe to a daily email list. So if you do that, every morning in your inbox is going to appear a list um, uh, of the papers that have come onto the archive for that morning. And you can filter it by topic. And probably if you're a young researcher, about 90% of those papers aren't going to be very interesting to you. But it's really good to go through those, um, maybe look at a few of the abstracts. If something looks interesting to you, maybe go give it a quick read. This is mostly for the benefit of staying up to date on what's going on in your field. It can be very easy to just focus on your specific subtopic that you're working on, and sort of forget to stay up to date on what's happening, what other people are publishing in the field. So it's just a way to encourage a good reading habit. All right. So once I've found my paper, how do I read it? This is a question that I've had quite a lot from students, because a lot of more inexperienced researchers make the mistake of thinking that you have to read a paper like a storybook. You have to read it from the beginning to the end, word for word. For the most part, if you are still a newcomer to a topic, that's really not going to be very useful for you. It's going to be a bit of a waste of time because about 90% of the information is just going to go straight over your head. So I find a better practice with reading papers is to know beforehand what you want to get out of it. So the first thing I do when I get a new paper is I open it up, I page through the pages, trying to get a sense for what the structure of the paper is, look at the abstract, what is this paper trying to do. And then from there, your interaction with the paper is very much going to depend on your level of familiarity with the topic. So if you are completely new to a field, usually what's going to be useful to you is to read through the introduction, because the introduction creates kind of the context for the paper, tells you why is this research being done, how does it fit into the context of the other research that's being done in the field. Then you probably want to skip over the methods and analysis or observation sections. It's going to be over your head. Maybe go through some of the figures, trying to see what kind of results are people getting, what are the basic sort of measures for data, and then maybe go over the conclusions. Once you are more experienced on the topic, you start to have a feel for what's going on in that. Your reading process changes a bit, because you start reading not to gain the context of what this research is about. You're starting to read for process. You want to know how this research has been conducted, what are the steps that they followed, so that I could potentially replicate it from my own work. So typically you would kind of glance over the abstract, probably skip the introduction, because if you already know what's going on, and then go through in detail in the methods. Possibly take notes as to exactly what software they use, what steps that they use. All of that will be very useful for you to know if you want to then apply that specific analysis to your work. And then maybe look at the results a bit, look at the kind of results that they get. So what kind of output would you expect if you were to apply this to your problem? And then finally, once you are an expert on a topic, once you know pretty well what's going on, again, it changes. You kind of look at the abstract a bit, skip all the way to the discussion to see what they have to say, and then go through the references to see if they cited your paper. So at that stage, you're reading to understand to see how that paper can enhance your understanding of the topic, see how it could affect your research. How can I incorporate this into my research? What can I do with this? So I hope that helps with reading papers. It takes a long time to get used to academic papers. Right. Next, so once I've done a bunch of reading, how do I write a paper? So this is going to differ quite strongly depending on your subtopic, your subfield. In observational radio astronomy, at least, there exists this kind of research cycle. It's going to be different if you're doing theory or instrumentation or something like this, but in observational astronomy, at least, it's all based on this cycle where you submit a proposal to observe using a telescope. You analyze the data from the telescope, get some results, write up a paper about those results, and then based on the results that you get from your analysis, you propose again to get more observation, new data that you can for certain purposes. So you have to justify in your proposal, why do I want new observations of this source? What am I going to be able to say from them based on my previous research? So usually at like MSc level, you sign on with a project that already has data attached to it. Usually that's the case. So you don't have to submit observing proposals yourself. Your supervisor has already done that. At the PhD level, sometimes you have to submit proposals for yourself, depending on what the status is of your supervisor. So let's talk a bit about proposals. To illustrate the proposal cycle, I'm going to use Meerkat as an example. So Meerkat there are about 8,760 hours in a year. About 35% of that time is allocated to what they call open time proposals. So every year, a new open time proposal window opens up. It actually just opened up this week, closes in about a month. Then you have time to write up a document of a few pages with a specific format, and you tell them why I want to use the telescope for how many hours, what different pointings I want to have. And that amounts to about 35% of time on the telescope. And again, these are for the most part yearly proposals. So every year you have to reapply to use the telescope. With some exceptions, I believe there are some multi-year proposals as well. But yeah, 35% goes to open time proposals. 60% go to the large survey projects. So these are proposals that have been submitted years and years ago already, where some really big names in the field proposed to have a certain set number of hours that they are guaranteed over a long period. a period of a couple of years, I think 5 years, 6 years. Um, and they get a guaranteed number of times. So there are 12 LSPs, and they cover different topics. Some are, so, Mighty Thundercat, Mongoose, Meertrap, Thundercat, all of these names, some of them you've probably heard of before. They are large survey projects. So the proposal there has already been done years ago. People involved in LSPs, of course, can still submit open time proposals, but the LSP time is guaranteed. And then there's also a buffer time of about 5% of observing time. That's for two reasons. The first is that sometimes the telescope goes down. There's a breakage in observations for whatever reasons, maintenance time. And so it's useful to have a little buffer in the schedule so that you can move around schedule blocks as need be. And then the second reason is you don't want to schedule all of your observations a year in advance, because sometimes interesting things happen in the middle of the year. So maybe there's a really cool new discovery at a different telescope, and we want to use Meerkat to look at that rapidly, or there's some new transient that we want to look at. In that case, you can submit what's called a director's discretionary time proposal, where you basically write to the director of Meerkat, send him an email and say, please, we want to use Meerkat to do this and this observation as soon as possible. And then if you're very lucky, you might get some DDT time. Right. So the last thing on research methodology that I want to talk about is just some general tips. And again, this is all based on my personal experience. What's been useful to me may or may not be as useful to you. But personally, for me, my number one rule that I've learned the hard way, to be fair, is don't get stuck. So radio astronomy is a really difficult thing to do. It takes about 10 years of education just to get your foot sort of in the door. And then for a very long time after that, you still kind of feel like uh, an idiot. It takes a very long time just to establish yourself and start to feel like you have a handle on things. So the soonest that you start to get discouraged or start to feel that this isn't fun anymore is when you get stuck. If you um, are at a particular problem and you can't make any progress and you don't know what to do, that's when you get discouraged. And the best remedy for that is to ask for help. So, fortunately, astronomy and science in general is a collaborative thing. It's not supposed to be competitive. There's a competitive element to it, which we'll talk about later, but um, usually people are really good about this. There are postdocs and staff and more senior students who all of them have. There will always be somebody who's encountered that project, that problem before. The best thing is just ask for help. It's not giving up to ask for help. It's part of the research process. The next tip that I have is another thing that's related to making sure that you have that sense of progression in your work, which is to check in with your supervisor regularly. So I know different supervisors have different philosophies when it comes to student supervision. Some are very hands-on, some are very hands-off. My advice on that is to, even if you don't have a daily or weekly meeting with your supervisor, um, at least give them regular updates on where you are. Tell them, this is what I've been doing this week. This is what I've been struggling with. This is where I'm stuck. It's your supervisor's job to help you out if you're stuck. So um, I find this is a good practice to keep yourself accountable as well, so you don't spend weeks and weeks not making any progress. And yeah, that sense of progression in your work and feeling that you're working towards something is very important. My third tip is read as much as you can. Um, all cards on the table. I find reading really boring. I like doing stuff, and I like teaching, and I like programming. Reading it boring to me. Um, but unfortunately, it's a part of the research process. You have to read papers, you have to read books, you have to um, broaden your horizon that way. It's the best reading is the best way that you can improve yourself and uh, improve your grasp on a topic. So yeah, there's no way of getting around that. Next, I recommend practicing writing. Academic writing is a whole beast of its own. It takes a lot of practice to get good at it. I find a lot of students, science students, you never really in your undergraduate experience anything that requires academic writing of you. You never have to submit so much as an essay. So the last time that you've written anything is probably in the high school. So, um, so yeah, when you start out writing, especially if it's your second or third or fourth language, can be pretty tough. So you submit some piece of writing to your supervisor, and that comes back full of red marks. Don't be discouraged. Just fix those, do it over and over again, and eventually um, you'll get better. Yeah. And then final tip, help other people with problems that they're having. It's a big cliche in teaching, but the best way to learn something is to help people, other people understand it. But it's true. Explain your research to your peers, tell them what you're doing, explain to them top subjects that they don't understand. Right. So that brings me to the second topic for today, which is what radio astronomy in South Africa looks like. And again, very limited perspective on my part. This is just my impressions for the most part. So first question, where can I do radio astronomy in South Africa? So I've listed the major universities in South Africa here and listed the number of staff and postdocs that they have. This is based on uh, a survey that was done earlier this year of counting all of the astronomers in South Africa at different universities. And I've ordered them here in order of how many radio people I saw on the list. So I may have missed some people, may have miscounted in some places. But the quite far and away the biggest university in terms of astronomy in South Africa is University of Cape Town. They have 32 staff and 13 postdocs, and I didn't do an exact count, but they have a pretty strong radio presence there. I'm guessing at least like 15 people working on radio currently. University of Western Cape also pretty prominent. They have a smallest faculty, 13 staff and 10 postdocs, but most of them actually doing radio astronomy. Rhodes is another big one. That's where Oleg Smirnov, who talked to us yesterday, is from. They have 10 staff and 4 postdocs, but most of them are doing radio astronomy. They have a really strong radio astronomy research group there. And then by my count, maybe wrong, but by my count, Unisa is now tied for fourth in terms of radio astronomy presence in South Africa, tied with Northwest University, which is my and James's previous institution. So NWU has a way larger faculty, 19 staff and 13 postdocs, but they mostly do other astronomy besides radio astronomy. So we have only 4 staff and 3 postdocs, but if I'm not mistaken, we have about 5 people actively working in radio astronomy research. There are a few others at different universities, UKZN, WITS, and then mine, 1 or 2 people at the rest of the universities. So besides the universities, there's also the South African Radio Astronomy Observatory, SARAO. So SARAO is a facility of the National Research Foundation. So it's a government-funded and government-run institution. And they administer and organize the radio astronomy in South Africa. So they are in charge of running the Meerkat telescope and a bunch of other stuff as well. So I've included an organizational chart at the bottom here. You'll see they have a managing director, an executive assistant, and then probably the two, and then the rest of the operation of SARAO is divided into these 7 subdivisions. The 2 that you may have some contact with, and the names that you should probably try to remember, is the head of the Science and Research Department. The chief scientist is Dr. Fernando Camilo. So if you submit a DDT, you submit it directly to Fernando, and he is sort of the guy in charge of organizing Meerkat, and ultimately responsible for arranging the different schedule blocks and so on. There's also the chief technologist, is Professor Justin Jonas. If you were at the Meerkat at 5 meeting earlier this year, he gave or was a big part of the talks there. There was a big person involved with the actual construction of Meerkat. So yeah. Right. Another really important question is what does the future hold for South Africa? And they, in radio astronomy terms, it's all about the square kilometer array. So just in case you don't know about the SKA, I'm sure you will do. The SKA is administered by the SKA organization, SKAO, which has a new headquarters at Jodrell Bank in the UK. South Africa is one of the 16 member countries, and we're also hosting SKA Mid. So SKA will be divided into 2 portions, SKA Mid in South Africa and SKA Low in Australia. And Meerkat is a predecessor or precursor to SKA. So the idea is that Meerkat is going to get expanded. More dishes are going to be added to Meerkat to eventually form SKA Mid. Construction opened 5 December 2022, about a year and a half ago. And the first dish for SKA Mid just arrived in South Africa earlier this year. SKA 1 Mid, so that's the first phase of SKA Mid. It's going to consist of about 200 dishes. I think it's actually 197. And the source that I found said that they were expecting completion by the end of 2027. As far as I know, people are saying it's probably going to be closer to 2028 or 29. And then phase 2, SKA 2, is a possible enlargement of SKA 1. As far as I know, that's still a possibility. It's not certain. In around the early 2030s, which will consist of a major upgrade of SKA. But I'm not sure if the exact details of that are public yet. And then also there's going to be very likely expansion into a number of Southern African countries or sub-Saharan African countries. These in the list, and there will probably be outrigger stations and dishes in these countries. So hopefully there's going to be opportunities for researchers in these countries as well to work with this connect. What is the significance of this for South African astronomers? So the South African government has put in a huge sum of money into Meerkat and the SKA. As you can imagine, it's going to be a huge deal, the biggest, most sensitive radio telescope ever constructed, and the government is pretty committed to making sure that South African astronomers play a significant part in that. So in the last couple of years, maybe 10 years, 20 years, they have really started pumping money into South African astronomy, especially radio astronomy, with the interest of in the interest of training new young scientists to be able to work on the SKA. A lot of you will be aware of the NASP program, National Astrophysics and Space Science Program, which administers student bursaries, honors, and master's level bursaries for astronomy students in South Africa. That's had a huge impact already. I'm one of the earliest people who benefited from NASP. Earlier this year, there was this headline about this that said 20 years ago, South Africa had 40 qualified astronomers, all of them white. Since then, NASP has pushed through 439 honors graduates and 250 master's degrees. So there's a pretty huge expansion of the South African radio astronomy community in the last few years. And hopefully in the SK era as well, we're going to be involved in that. And I encourage people who are interested in radio astronomy. It's a really huge opportunity for us to be part of the SKA. It's just a brilliant opportunity. So if you're at all interested in radio astronomy, I recommend learning to use Meerkat, get involved in Meerkat science. It's going to put you in a really good position for the SKA era. Right. So the final topic that I want to talk about today is, in case you decide that you really do want to make a career out of astronomy, what does a typical career in astronomy look like? And again, typical is a keyword there. Everybody is going to have a different experience. This is kind of the diagram that I have here is explaining the basic kind of progression structure that exists in universities for progressing all the way from your bachelor's and honors years to MSc to PhD, all the way up to being a professor. So the usual picture is that you do your studies for about 10 years, more or less, and then you start looking for research positions. So if you are very lucky, you can get a junior lecturer position. So that's a full-time position at a university, mainly focused on lecturing students. If you're not quite as lucky, you can do a postdoc, which is doing all the same responsibilities as a junior lecturer. But basically, but it's a contract position, so you get contracted for say 2 or 3 or 4 or 5 years, and there's usually stipulated that you need to meet a certain criteria every year for your contract to be renewed. And you can do a number of postdocs. Some people do none, some people do 4 or 5. Some people move around the world every few years chasing a new postdoc, and waiting for a lecturer position to open up. So um, here a lot of the time your success in getting a permanent position at a university is going to depend on how willing you are to wait for a permanent position to open up. Are you willing to move you and your family around from university to university, and hoping and waiting that the position opens up for a lecturer? Other times you're lucky. So in order to get a lecturer position, a new faculty position must open up. So either a new position must be created by the university, or you have to wait for somebody to um, go out of that position. So, and um, the way things work is that oftentimes people stay in the same position once they have a full-time position. They stay in it, and don't tend to leave until they have to. So it's very much dependent on luck to a large degree whether you actually get a full-time position. But if you do get a lecturer position, you can make your way up to a senior lecturer, an associate professor, eventually a full professor, and then professor emeritus, which is basically a retired professor. Your progression within this structure is based a lot on your NRF rating, which I'll get to in a second. But first, I want to give you some notion of what is expected of a researcher at each stage of their career. So if you're doing an MSc, you probably know this, but your main task is to produce some original research in a thesis format. So that's usually in astronomy about 50 to, I've seen 200 pages even. It's good if you can publish in a peer-reviewed journal and present at a conference. These are all good to have on your CV, but it's not 100% necessary. If you get a PhD position, you have to submit at the end a thesis of about 150 to 350 pages, depending on your topic. Some countries require that you do an oral defense. Where I was in Manchester in the UK, we had to do that. It's called a viva. In South Africa, I don't think that's the case. You just submit the thesis. Usually, you're also kind of expected to publish about 2 to 3 papers. It's not strictly necessary to graduate your PhD, but if you are interested in doing a postdoc or getting a position after your PhD, 2 to 3 papers is about the standard. And then, of course, you have to speak at conferences, submit proposals is a good thing to have on your CV. Do some outreach. All of these things are useful. When you get to postdoc level, you're expected to publish a certain number of outputs. So usually about 1 to 2 first author papers per year. Each university has a different set of standards for what's expected of a postdoc. It's listed in your memorandum of understanding. Oftentimes, you're also expected to teach some modules and to supervise some student projects. Again, that will be stipulated in your contract, but those 2 things, teaching and supervision, is a big a boost if you want to eventually get a lecturer position. If you do get a lecturer position, you basically do the same things, just not on a contract basis. Professorship, again, works on the NRF rating. I'll explain that in a second. But if you're a professor, you're expected to do the same things as a lecturer, but you also have to referee some journals, be an examiner, external examiner at other universities for modules and student projects, uh, to teach and supervise, and you have to start playing an active role in running faculty. Um, uh, Sometimes you are expected to take on a directorship role as well. Right. So I said that your progression on this ladder depends on your NRF rating. So the National Research Foundation has this uh, does this thing where they review um, your record every couple of years. I think it's 5 years, maybe. Somebody could correct me on that. They look at how many papers you've published, how many students you've pushed through, um, how you lectured, your activity in the faculty, and they assign you a grade. So this is a list of all the grades that you can get. You can get a Y rating, which is basically a young researcher, fewer than 5 years from your PhD. That's typically like a junior lecturer position. You can get a P rating if you're especially promising. That's sort of like a junior or senior lecturer, sometimes potentially an associate professor. A C rating, A, B, and C. C rating is where you start to become a senior lecturer and associate professor. And then at a lot of universities, I believe the prerequisite is that you have to be at least B rated to be to become a professor. And then A rating is pretty much means you're at the top of your field. You're an internationally renowned expert on your field. Right. So where can I find different projects and jobs? I put down a bunch of different sources here. A really very useful one is the SA Astronomers mailing list. If you're not on this mailing list, you can subscribe by sending an email to this address. And that is a super useful tool. They send out basically any news that's relevant to South African astronomers. They send reminders about different conferences that are happening, different deadlines for proposals and the like of that. And then they very often send out if a position is being advertised, MSc and PhD projects and staff positions very often get advertised on that list. The SARAO and SAO websites, also both of them have on their websites listings of vacancies and project opportunities. The NASP website, this has a list of honors and MSc projects that you can do. I know all or most of you already have an MSc project, but this is a useful tool if you don't. The NASP projects come attached with a bursary, and you can do the project at any university in South Africa, or any one of, I think, three or four. Um, PNet is a South African jobs website. Um, Faculty positions often get advertised on there. They also have some a lot of non-academic positions. I'll talk about that in a second. So maybe you find your next job on there. Findaphd.com. This is actually where I found my PhD. It's an international website. So if you're interested in potentially doing your PhD overseas, this is a cool website that advertises from a lot of different universities around the world. The AAS job register has a listing for different positions available at all different levels. This is really useful. and physics. They also has a jobs listing. This is more in the physics world, so not all of it is astronomy. And then really important, a lot of the time it works out just by word of mouth. If you collaborate with a researcher on a project, and they find that you're doing good work and they like you, then they might want to lure you over into their group, and then they can make a position for you a lot of the time. So my recommendation is discuss if you're looking for PhD projects, or postdocs, discuss that with your supervisor. They can put out the word that you're in the market looking for something. Oftentimes they know about somebody who's looking for somebody who can do the work that you're doing. So yeah, just put your name out there. Right then, what are the things that I can do besides academia? Because as I showed a bit earlier, to a large extent, your chances for progressing in astronomy career, in academic career at least, is fairly luck based, to be quite honest. It depends a lot on what faculties are looking for at a particular point in time. If your specific subtopic of radio astronomy is not considered popular at a given moment, then you might find it quite difficult to find a position somewhere. Um, there are a lot of decisions that go into getting academic jobs that go beyond just how competent somebody is, unfortunately. So the reality is that the majority of people who start out getting PhDs in astronomy and physics don't end up in becoming an academic. So, but the fortunate thing is that physics and astronomy is a really good degree anyway. It teaches you a lot of skills that are marketable in other directions. So keep an open mind on this. I've listed a bunch of different things that you can work on. You can a really nice thing that you can do is you can work as an instrumentalist or telescope operator at Sorel, for instance. If you get really good at radio interferometry, there's a lot of signal processing applications that you could be suited for, like telecoms. I've heard people going to telecoms. Software development is a big thing. Especially if you get into something like machine learning, that is very sought after, or other like big data type of software development, that's very highly sought after, and you should be able to get a pretty good job off of that. You can work in a aerospace industry potentially. A lot of people get experience in simulation and modeling. So, for example, financial modeling. So, I believe in the UK, it's the case that the biggest employer for physics PhDs is Barclays Bank. So, a lot of people go from doing physics to using simulations and modeling in financial and banking industries. You can work in a patent office like Einstein, a museum or a science center. There's journalist positions, and then teaching. So yeah, a lot out there that you can do. And then finally, this is the final tip. I see which is about over the hour mark. I just want to give some very general tips, um, with again all the necessary caveats. The first is, for building a career in astronomy, your relationships with people is very important. A lot of the times, if you know the right person, if you know somebody who's doing specific kind of work, and you build a strong relationship with them, and you demonstrate that you are a capable person, that you are able to work in a group, that's very important, to show that you can work together with other people. As I say, physics, especially radio astronomy, is a very collaborative science. So you have to be able to work with people and demonstrate that you have worth in an organization context. So probably the only thing second to the people that you learn to know is your publishing record. So unfortunately, it's the case that there's a culture of publish, 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 publish or perish, where um, your number of publications is an easily sort of quantifiable measure of your record in academia, and the more that you publish, the better rating that you get, and the more likely that you are to get jobs. So um, yeah, it's an unfortunate reality about the field, but that's true about academia in general. Third thing I want to emphasize is rejection is not failure. In your astronomy career, you're going to probably submit a lot of applications for observing time, for jobs, for positions, for grants, for fellowships, and get turned down a lot. It's just a matter of there's a lot of competition out there. A lot of the time, they're looking for a specific thing, a specific person. It's really not personal. Don't take it as you have failed if you get rejected for a position or for a grant. It's part of the process. Try to apply for as much as you can. Increase your chances. It's in the end, it's to a large degree a numbers game and a waiting game. Next, I've already talked about this. Academia is not the only option. There's a lot that you can do out there. I know a lot of people who did really brilliant work in astronomy and in physics, and just and then went on to really fruitful careers in other uh, areas. So it's yeah, don't blind yourself to other options. Next, don't compare yourself to other people. In the first place, everybody's experience is very different. There's so much that goes into what makes somebody a success that's really out of their control in a lot of instances. And also, it's very difficult to get a real sense for how successful somebody else is. You only see the good parts or the successes. You don't necessarily see the failures. And everybody has those failures. Uh, Another really important thing that I have had to learn as well, resting is part of the process. Don't um, think that you have to be working 100% of the time. It's healthy to have a balance. Uh, my experience of research is that it's very up and down. Sometimes you have go through periods where you're really not very productive. You can't do anything, and then other times where it's hectic and you have deadlines and you're just working late into the night every night. So on those quiet times of research, don't blame yourself or don't get down on yourself. It's all part of the process. If you're resting, then rest well. Don't sit there thinking about all that you have to do. And then final thing, probably the most important thing I want to convey to new students here is to know your worth. Academia and research, to a large extent, is dependent on the work of students and early career researchers. Students and postdocs do a lot of the donkey work in research. So your research is really valuable, even if it doesn't feel that way. And remember, if you are at the stage where you're doing an MSc or PhD in astronomy, you have lots of skills that are sought after in other places. So know that you have other options. Don't feel that you're doing that anybody is doing you a favor by giving you a position. Those are my messages for today. Hope that was useful. Let's go over to see if there are some questions, anything that you guys are wondering about.
Hi, sir.
Yes.
So apologies for the late coming. I just want to know,
Okay.
like, how do you read a journal article in astronomy?
That's a good question, and it's one that I covered before you arrived in the meeting. So I covered that in quite detail. So I recommend just watching the video. I'm going to post it directly after this. No problem. Again, okay. You guys are welcome to send me an email anytime you're wondering about something. If you're too shy to mention it in the chat. Going to give another small opportunity for questions, and then I'm going to talk shortly about the rest of this semester's lectures. Yes, I'll share the slides to the group as well. Okay, gone. Cool. No problem. So let me share my screen again, and we can look at the rest of the schedule for these lectures. So we're going to be doing these every 2 weeks. I have a, a schedule up. This is liable to change as circumstances change. If there's meetings or travel coming up, I might just shuffle this around. So for the first, what's it, 3 weeks, we're going to do a crash course on radio signals. On radio signals and emission processes, propagation of radio waves, that kind of thing. We'll have 1 week talking about positional astronomy. So this is a really annoying topic, but coordinate systems, I hate with a passion all of the different conflicting coordinate systems that we have in astronomy. They annoy me very much, but it's necessary to learn them and learn how what the different systems are used and how to convert between them. Then I'm going to do about 3 weeks on radio telescopes. First, introduce some basics on the antenna elements, dishes, and then 2 weeks on interferometry. Then I'm going to have 3 weeks on assorted topics, some time domain astronomy, a bit of radio stars. So I hope that's all okay. If you have any suggestions or requests, you can just send me. Yeah, the question in the chat, we have a copy of the textbook. Before every lecture, I will send out the reading material for that week. So I'll make a copy. I'm not going to send the full textbook, but I'll extract the portion that we'll use. Patrick, your hand is up, I think.
Hello, Tian. Thank you
Hi,
for wonderful presentation.
no problem.
My question is on at which stage will a young student or a young researcher in the process of academic will start making physical observations, or at which stage will I make observation using maybe, for example, the meerkat observation or which skills, and also which skills do I need to have learned before, or there will be some engineers that will guide me in the observatory center? Thank you.
Yeah, okay, thanks for that, Patrick. That's a really good question. So in large part, that's going to depend on your project. So if you sign on to an MSc project that already has observations attached to it, you probably won't have to do the observations yourself. I started doing observations during my PhD. But again, that's for modern radio telescopes, at least, that's all done remotely. So Meerkat has an observing portal. You just basically submit the coordinates that you want to look at, some parameters for the observation, and then the observation itself is done automatically. With other telescopes, Parkes telescope, there's also an observing portal where you have to start and stop the telescope, where it's necessary for you to have some training before you use a telescope. The telescope itself will give you some training on that. But for the most part, radio astronomers don't have to go out into a jungle in the middle of the night or to a mountaintop to look at stars, because it's all digitized and it's all remote. I think that's different in optical astronomy and so on. Any other comments on that or questions?
Hello, Tian.
Hi, Joseph.
Yeah, may I make this suggestion? Is it possible sometimes along this series of lectures, we have some, you can direct us to obtain some data as well as some softwares where we can use them to practice analyzing and perhaps making images of such data also?
Yeah, getting data is always a bit of a tricky subject, and the tenor of the lectures are going to be more sort of theoretical. So I'm not really going to go into the details of how you make an image, for instance, in the first place, because I am not really familiar with imaging. I haven't done imaging before. The specific techniques of data analysis that I am familiar with are like pulsar data, filter bank files, which I don't think most of you are actually going to work with or going to find useful. So where I can, I will point you guys to where you can find some tutorials and some data possibly. But for the most part, it's going to be theoretical. Hope that answers your question.
Yes, thank you.
Okay, cool. I think we'll leave it there then. Again, my emails are open. And then I'll see you again in 2 weeks' time, 28th of June. And I'll send out these chapters of the textbook for you to read before then. All right. Cheers, everyone.
Thank you, Tian.
Thanks, Tian.
Okay, no problem. Cheers.
Thank you.
Thanks, Tian.
Bye-bye.
Thank you, Mr. Tian. I enjoyed the lecture.